Hello everybody and welcome to our first lesson in Unit 2, Formulas and Constructions. The objectives for today are I will be able to find the midpoint of a segment in the coordinate plane. I will be able to find an endpoint given a midpoint and endpoint of a segment. And I will be able to copy and bisect a segment using a compass and straight edge. So let's get started. Before we can talk about finding a midpoint, we need to talk about congruent segments. Congruent segments have the same length. If you look at these two segments, EF and GH, and if you were to measure them with a ruler, you would find out that they both have the length of 3 centimeters. Both are 3 centimeters long, and that means they are congruent, which we can indicate with a little hash mark like that. So what we're saying is EF, the length of EF is 3 centimeters, the length of GH is 3 centimeters. Therefore, remember our therefore from the previous unit, the length of EF is equal to the length of GH. So here we're talking about the lengths being the same or equal. And therefore, following in our logic argument, the segments EF, remember segments we write with the letters of the beginning and end point and the line above it that has no arrows. The segment EF is congruent, and we use an equal sign with a little squiggly above it, congruent to the segment GH. This is about segments, but the segments are congruent. But in order for segments to be congruent, they don't have to be separate. Let's look at this segment AC, and that has a midpoint B. So if we look at the partial segment AB, that segment AB is congruent to the segment BC. Therefore, B is the midpoint. B is the midpoint of AC. And again, we can indicate the fact that AB and BC are congruent by making little hash marks like this. So what then is the midpoint of a segment? The midpoint is a point and it divides the segment into two congruent parts. Let's assume we have the midpoint right here, and this midpoint divides segment AB into two congruent segments. One segment is AM, the other segment is MB. These two segments are congruent, and again we're gonna use our little hash marks to indicate this. A segment bisector is something a little different. A segment bisector can be a number of things. It can be a point, it can be a ray, it can be a line, a plane, or a segment. It can be a number of things, but it also intersects a segment at the midpoint. So this is our midpoint M. Segment bisector, in this case, I'm going to make it a line, intersects the segment AB at the midpoint. In other words, the segment bisector is a point, a ray, a line, a plane, or a segment, but what it does is it intersects a segment at its midpoint. Let's not forget our hash marks, which indicate to us that the segments AM and MB are congruent. And what I will also write is gonna make our line, give it a name, with a point C on it. So our line MC, and lines do have arrows on both sides, bisects the segment AB. You may have noticed that my hash marks, I made them all in red, and I used different numbers of hash marks. And it's important for you to remember that if we have several sets of congruent segments, then we have to vary the number of hash marks to indicate which pairs of these congruent segments are congruent to each other and which aren't. In other words, going back to our first example, EF is congruent to GH, but they are not congruent to AB or BC. And AB and BC are congruent to each other. That's why they have two hash marks. But EF and GH are congruent to each other, not to the other ones. That's why they only have one hash mark. Now I want you to stop the video for a minute and think about and write down in your left margin an example of your everyday life where it would come in handy, where it would come in useful to calculate a midpoint. This next part is not on your printed notes, so I just would like you to watch and listen. We are going to find the midpoint between points A and B on each of the two number lines, and we're going to label it as M on each number line. Let's look at our number line to the left, nice and horizontal like an x-axis. If we want to find the midpoint between these 2 points, one way to do it is to just count the number of steps from A to B. 1, 2, 3, 4, 5, 6. And then we think about what is half of that, how many steps is half of that, and that means 1, 2, 3 steps, which makes our midpoint M to be right here. Now let's look at the number line on the right, nice and vertical, like a, you knew it, a y-axis. And finding the midpoint between A and B on our vertical number line, we do the same thing. We count 1, 2, 3, 4, 5, 6 steps again. And let's then go ahead and count 3 steps, starting really from either one if you want, down 3 steps. And this is our midpoint. This was fairly easy, and we can do this as long as the numbers are fairly slow. Sometimes the numbers aren't that small, and therefore maybe there's another way to find the midpoint between 2 points. So I want you to stop the video and in the margin of your notes, describe another way that you can think about where you can find the midpoint between 2 points. What is another quick way to find the midpoint? Maybe you thought about averages. How can we use averages to find the midpoint of 2 points? We'll take the coordinates of the 2 points. I'm going now to the left example. The coordinate of A is -2. Add that to B, which is 4, and divide it by 2. -2 plus 4 is 2, divided by 2, that's 1. And our other midpoint, A was 9 and B is 3. Add these two together, divide by 2. 12 divided by 2 is 6. So let's look at our two midpoints. The midpoint on the left is indeed at 1, and the midpoint on the right is indeed at 6. So this is another easy way to find midpoints, and it is particularly handy when the numbers are far apart and it's not that easy for us to count the steps from one point to another on a coordinate plane. So then let's go ahead and find a midpoint in a coordinate plane. We've got an example right here, and we are supposed to find the midpoint of the segment with these endpoints. C with the coordinates 6 and 1, and D with the coordinates 2 and 9. First off, I have not put the coordinate plane in here yet, because I want us to have the possibility to choose it depending on the coordinates that we find. These are all positive, so I will put my coordinate plane in like this. My y-axis and my x-axis. And so my points are C is at 6, 1, and D is at 2, 9. Here are our 2 points, and I'm going to connect these 2 points with a segment. We are supposed to find the midpoint of this segment, and as we have done in the previous examples, we can count out the steps. We have to count in 2 dimensions now. Remember, on our coordinate plane, we can not only count from left to right and up and down. We cannot go across diagonally. So let's count how much higher is D compared to C. 1, 2, 3, 4, 5, 6, 7, 8. And half of 8 is 4. 1, 2, 3, 4. And let's count how much further is C to the right compared to D. 1, 2, 3, 4. And half of that is 1, 2. And here we have our midpoint. And our midpoint has the coordinates 4 and 5. But remember, not always is it as easy to count out the points, so therefore we can use the midpoint formula, and the midpoint formula uses the averages, as we have just discussed before. First of all, it's a formula that finds points. So the points, remember, we show as an ordered pair. And in order to find the x-coordinate of the midpoint, we add x1 plus x2 divided by 2. And we also add y1 plus y2 divided by 2. Now this formula is super important, you guys, so I want you to mark it whichever way you can with asterisks, highlight it, whatever makes you remember this formula. It is very important. So going back to our example and using the formula with our example, let's just mark our coordinates here that we have. This is x1, x2, y1, and y2. And we're going to go ahead now and plug those numbers into the formula. 6 plus 2 divided by 2, that's going to be the x-coordinate, and 1 plus 9 divided by 2 is going to be the y-coordinate. Solving, simplifying, we get 8 over 2, 10 over 2. In other words, the coordinates of our midpoint M are 4 and 5. Looking over to the left, we see that is exactly what we also found when we counted it out. So we get to the same answer, good for us, and this formula is easy and can be used very well when the numbers are further apart and counting is a little difficult. Now let's then move to another example where the midpoint is given, and so is one of the two endpoints, but we are supposed to find the other endpoint called k in this case. Looking at our given coordinates, we can decide to put our coordinate plane again like we did in the previous example. We have only positive coordinates. And let's put in there the things we have. The endpoint J is at 0, 1. And our midpoint is at 4, 2. This is our midpoint. In other words, we know that our segment goes like this, and then it'll go somewhere in this area. This is where we will find k, but we don't know exactly where. So let's use our formula and find the other endpoint k. This time we don't have x2 and y2, so we need to use the variables. So using the coordinates for j, we can write 0 plus x divided by 2 is equal to 4, which is the x-coordinate of our midpoint. And 1 plus y is equal to 2, which is the y-coordinate, divided by 2 is equal to 2, which is the y-coordinate of the midpoint. All right, let's go ahead and solve this. We don't like our fraction with the 2 in the denominator, so we're going to multiply both sides by 2, and we get 0 plus x, in other words, x is equal to 8. Do the same thing to our equation on the right. Multiply both sides by 2. And we will get 1 plus y is equal to 4. Subtract 1, y is equal to 3. So our point K, our endpoint K, has the coordinates 8 and 3. If we count this out, 1, 2, 3, 4, 5, 6, 7, 8, and 3. This is and the day has just started. This is where the endpoint K is. Alright, that concludes the first part of the video. Now go ahead and watch the second part.